Okay, so now in this series you're going to be learning how to calculate the sum of an arithmetic series. How can we add the terms of an arithmetic series? So now let's look at this example first and see how this goes. Now let's say we have an arithmetic series which has 1, 3, 5, 7 and 9 and so on. As you can see that these are just the sequence of odd numbers. We now know how to find the general term of this sequence. We know that we first have to find the difference. So this is going to be 2, 2 and 2. Okay. And when we want to find the general term of the sequence, we are just going to write Tn equal to A plus n minus 1 times D. But let me leave that to you to try to find the general term of this sequence. Okay, now that I've tried, we are going to continue and say this is 1 plus n minus 1, D is just 2. We are going to end up with 1 plus 2n minus 2, which is going to be 2n minus 1. Because 1 minus 2, that's just negative 1. Okay. So using this general term, we can therefore calculate any term of this pattern, whether it's the 10th term, the 100th term, the billionth term. You can just calculate any term using the general formula. Alright, but what if we want to find the sum? Okay, what if we want to add the terms of this sequence? Now when we are adding, it's no longer a sequence, but it's now a series. So there's a different terminology when we are adding. So 1 plus 3. Now this is a series since I'm adding plus 5, plus 7, plus 9, plus dot dot dot, which means the series continues. Okay, so when I'm adding the first two terms, so this is the first term and the second term. So when I'm adding the first, so that would be T1 plus T2, I'm going to get 4. Okay, just adding T1 and T2. So this is T3, 4 and 5. Now when I'm adding T1 plus T2 plus T3, which means I'm adding the first three terms of this series, I'm going to get 1 plus 3 plus 5, which is going to give me 9. Alright. So here when I'm saying T1 plus T2 equals to 4, this is the sum of the first two terms. Okay, since I was adding T1 and T2. So that's the sum of the first two terms. Now here, since I'm adding from T1 to T3, the first three terms of this series, that will be the sum, S for sum, of the first three terms. Okay, that's S3. Now let's add T1, T2, T3 and T4. So when we are doing that, we are going to get 16, that S4, which is just the sum of the first four terms of the series. Okay, now that could go on and add T1 plus T2 up to Tn. So that will be the sum of the n terms of this series. Okay. Now let's say we want to find S22. Now finding S22 is really going to be difficult when you are trying just to calculate using your calculator and you don't have a formula. Luckily, we have a formula for the arithmetic series. How can we sum the numbers and just plug in the number of terms? Okay. So the formula is, we are going to prove it later. It's n over 2, 2a plus n minus 1. So just like the general term, we can just plug in the number of terms, and then we just have the sum of those number of terms. Okay, so let's try S22. So we are going to try S22, which means whenever there's n, we are going to substitute 22. Let's substitute 22, okay, over 2. 2 times what is a? It was 1, plus n, that's 22. Substitute 22 minus 1. So you should have d here. So multiplied by d, which is 2. Okay. Now we are going to use our calculator to punch that. Right, so let's punch this on our calculator. This is going to be 22 over 2, brackets 2 times 1, plus 22 minus 1 times 2, close brackets. That's going to be 408. So this is equal to 484, sorry, 484. Alright, so that's how we can easily calculate the sum of the terms just using the formula. And let's say we want to calculate S48. Okay, let's do S48. So S48 will be, again, we substitute 48 where there is n, 48 over 2 times 1 plus 48 minus 1 times d, which is 2. Okay. Again, we'll just add it from what we did before. I'll get 2304, right? So that's how easily we just calculate the sum of any terms in this series. Alright, so now let's try to phrase the question a little bit different. As you saw, when we were calculating Tn, we used the general formula, which was Tn equals to maybe 2n minus 1. We can use this general formula to calculate any term in the sequence, like the value of any term, like T21, T48, and so forth. And we've also seen by just using the sum that since now we have the sum of the series, we can therefore calculate S21 and S48 and any just sum S50. Okay, we can use the formula to calculate that. But also what we did using Tn is that we were now able to find the term corresponding to a certain term value. Okay, so we could calculate which term in the sequence has a value of 91. Okay, so we have Tn equals to 2n minus 1. We want to know which term, which means n, which term n has a value that means that is Tn of 91. So we just equated this like that. So we did that, and we know we could solve this by just solving for n. Okay, so 91 plus 1 equals to 2n. This is 92 equals to 2n, and if we just divide by 2, we can get that n is just equals to 46. Okay. We can also do this by just using the series. We could say which number of terms have a sum of 10,000, for example. Which number of terms have a sum of 10,000? So you can see in this case we are given the sum, which means Sn, we are given Sn, that Sn is equals to 10,000, okay, in this case. And we want to find the number of terms, which means we want to find n. Okay, so this is the reverse process. So we can use our formula very easily. Let's first write it down. Plus n minus 1 times d. We have Sn, which means we have the sum from this question, and we can calculate n, the number of terms. So we have the sum, that the sum is equals to 10,000 in this case, and we want to solve for n. So this is going to be n over 2 times 1 plus n minus 1 times d, which is 2. Okay, so to solve for n, first thing we're going to do is to multiply by 2 both sides. Why? So that we can cancel this 2. Okay, so we can just cancel this and that, and then on this side we are going to be left with 20,000 equals to n 2 times 1, that's 2, plus 2 times 2, that's going to be 2n, 2 times negative 1, so it's going to be negative 2. Right, so this is going to be 20,000 equals to n, and then 2 minus 2, that's just going to be 2n. Right, so 20,000 is going to be 2n squared when you multiply 2n times n, that's going to be 2n squared. Again, we can divide by 2 both sides. Okay, and then we can see 2 will cancel 2, and then we are left with 20,000 divided by 2, which is just going to be 10,000 equals to n squared. And then let's take the square root both sides. We are going to be left with, let's just use our calculator for this case and say the square root of 10,000, that's just 100. So we can see that this is going to be n equals to 100. So the number of terms which have a sum of 10,000 is 100. Okay, so if I make a sum of all these terms from term number 1 and term number 2 up to making a sum up to term number 100, this is going to be 10,000. So this is a sum, not a term. So we can still calculate T100s and it's not 10,000. This is the sum of everything, T3, T4 up to T98 plus T99. So summing everything from term number 1 to term number 100, we are getting 10,000. So this is how we can use the formula of the sum to calculate the number of terms which are giving us a certain sum.